Okay. Maybe make this double space. It's just hard to read it. How have we got? All right. I'm going to get to where we can look at it together. All right. Share. Okay. So our goal here is to answer her questions. But actually, you can actually see here. So it's not as bad as it first seems. Like the initial shock wears off, and you realize, okay. He says here 2 to 3 major similarities or differences. We actually already have that, which is good. But then she says, well, you don't need to get into which one you think is better, but that's the whole point of the thesis. The thesis is to say which is better, or
Mm-hmm.
why you should read the book or not read the book, or watch the movie or not watch the movie.
Right.
Okay, so we actually have already done this, and let's all we're going to do is go read what we wrote, and uh, so the first uh, similarity or difference is the account of the transition of Jack from normal to insane. Would you say that's a similarity or a difference?
Um, for that it's a similarity.
So the I think it's a difference. Because we actually claim that it's better, but it is a similarity in the sense that they both cover it. But you said that the book was better at covering it.
Oh yeah, I did say
So
that.
so we can say that here. We can say the book gives and we'll just copy our sentences because why would we redo what we've already done? So the book gives a more comprehensive account of the transition of Jack from normal to insane. Okay. What are you saying here in this next topic sentence? What does that tell you?
Um, it's telling us that the movie is scarier with like visual effects and than the book because we get a better picture basically.
So is that a
Like what
similarity or a difference based on kind
that's
of
a
like,
difference.
yeah, so we want to say that here. Okay. And then let's go down to the uh uh last couple of paragraphs here. What are we talking about here? What's kind of the main idea here?
Um, it's talking about how the book has better character development than the movie.
Exactly. And is that a similarity or a difference?
That's a difference.
Yes. Okay. Uh, so let's grab that. Okay. So uh, we have done what he asked for here. Okay.
Mm-hmm.
We have actually gone further and said which is better because we are, you already wrote the essay. Um, and then your thesis here is right here. This is your thesis. So let's see if she will accept this and move on to new stuff. So I'm gonna put this in the chat. Hopefully it'll all fit. It does not. Okay. Um, I'll save this and then you'll know that the essay starts here and just submit the, does that work for you?
Yeah, that works.
Do you I'm sort of pushy with this stuff. Are you comfortable with what we're doing here?
Yeah, I'm fine.
Okay. All right. I wouldn't be as kind as you're being to the instructor, but you're the student.
I'm just generally nice person.
You are a very nice person.
Thank
Um,
you.
uh, yeah, somehow the emoji just doesn't like work for me at the end there. Um,
Yeah, the emoji like threw me off. I'm like, why would you write that after you just basically crushed my soul? Like, come on.
exactly. Right. So if we're good on that, I'm going to uh save this and go back to something else, probably physical science.
Yeah, we can do physical science.
All right. Okay. File, save, no, share screen. Okay. So yesterday we talked about this idea of displacement and distance. Um, have you sort of walked around the entire ship that you're on?
Yeah, kind of.
Okay. Well, just think of like whatever room you're in. We'll just talk briefly about this again. Your room, think of your room as your starting point. And this
Okay.
idea of distance and displacement is, you went, this last one's the best example. It's like you went, you know, eight somewhere and 16 somewhere and eight somewhere else, but you ended up back at your room because you went, I don't know, left of your room, right of your room, and then back left to get to your room. So displacement is the distance from where you started, and distance is your total distance traveled. So that was the key
Gotcha.
idea we were talking about yesterday. And then we calculated some velocities and speeds. I made one modification to this. So speed is always, you're driving now, your speed is always positive. You never see a negative number on your speedometer, even if you're going backwards. Maybe you never thought about that, but that is the case here, that your speed is always positive.
Mm-hmm. Yeah, never
You,
thought of that.
yeah. And if you're going really fast forwards or backwards, or you're going down one side of the street and a car's coming at you from another side of the street, you guys are going opposite directions, but you have speed is always positive. Always positive. And math class or physics is actually just another name for math, truthfully. So if you have an option to take a physics class, you should just think math class and then decide if you really want to take it or not. Okay, ready to get going on this?
Yeah, I'm ready. Let's do this. To get over with, you know?
All right. We okay, so you throw a ball into the air. It reaches a certain height and then comes back down to you. On the way up, what are the directions of the velocity and the acceleration? Okay. So let's first talk about velocity. When you throw a ball up, it's moving up until it reaches the maximum height. Then, for
Mhm.
the briefest of moments, I don't even know how to say that, but briefest of moments, it has no velocity. So that's when you're sort of suspended in the air. That we said you had that trampoline,
Yeah.
water trampoline. It's that moment when you sort of you're just at the top and you're neither going up nor down, you're just floating in space. Uh, then then you start to fall. Okay, but we'll get to that in a moment. All right. Acceleration. Acceleration due to gravity always opposes motion on the way. So it's fighting you, which is the reason when you jump, you come back to Earth. Can you imagine jumping and just taking off? There's never coming back.
No.
That's what happens in space. You end up if you like push yourself away from the spaceship, you will never come, which is a bad
Yeah, you're
thing.
gone.
Yeah. So um, there's two things here, and acceleration is due to gravity. It always opposes motion on the way up. It fights you, meaning, and that's why you slow down. If you didn't, you would just go on forever, which would be really bad. And so, unfortunately, you're going to have to rewrite this information here, and these are kind of your notes. You're welcome to reuse some of the words, but you should try to put it into your own. Oh, sorry. Um, it slows down. And that's why the reason it slows down is because the ball slows down is because uh, gravity fights it. It makes the velocity get smaller and smaller. Think of uh, think of acceleration as like your brakes when you're driving. You slow down.
Mm-hmm. Got it.
So try to put, 1 to 2 sentences together here about the subject.
Okay. Here's what I wrote. I think I got what I don't know actually what I was about to say anyway.
Okay, so one of the things you're missing here in your first draft is you're not talking about the velocity um, on the way up. So yes,
Ew.
it does slow down and it does have no velocity, but what is its velocity on the way up? Is it positive or negative? I guess it didn't address that. The velocity is positive on the way up.
Yeah, they
There's
didn't get
also
that
no
mentioned.
there's also no mention of acceleration. So you might need another sentence there and add in that velocity is positive on the way up.
Okay.
Sorry, sometimes it does that.
So hold on. We said that when throwing the ball, it's gonna be positive, and then it goes negative, right?
Well, well,
When
the,
it's
the
going
negative
down.
the negative parts for part B.
Oh, okay. So I should just say when throwing the ball in the air, it's the velocity is positive.
On the way up. You have to add that part in because it's not always positive.
So like something like this, right? They wrote it in the
Okay, so we want to start with your second sentence. You're telling a story, and I think you're good at telling stories. It's just when you write them down, it's still
there's
um,
nothing.
it's lacking a little bit. Yeah, you want to start. Okay, the velocity is positive and throwing the ball uh, up in the air until its velocity is zero at the maximum height. You're telling a story. Okay, now tell me about the acceleration. What is going on with the acceleration?
Um, the acceleration is um I assume that when it's up in the air, the acceleration kind of dies down a little bit because as you can,
Oh,
it drops
so
in
the
back down.
acceleration always, and you can basically just reuse this sentence here, but it's always due to gravity and it's always constant.
Okay.
It slows the object down and it's always constant.
All right. So should I add that into the sentence?
Yes, yes, absolutely.
So something with like what I wrote in the chat work.
Uh, the acceleration of gravity is always so we're like we said, we're telling a story here. I'm gonna grab that last sentence. The acceleration of gravity always opposes motion on the way up, and so is the object uh, that you are throwing down. Okay, throws that's good. And so now you've answered the question. Perfect. Okay, like that's all that's needed. Two sentences. Now,
All right.
on the way down, you can basically reuse a lot of what's here, but on the way down, the velocity is pointing down and acceleration is also pointing down. You might want to say that they're going in the same direction. Okay. And then uh, the object actually speeds up. That's why when you hit the ground, you hit it with some measure of force because you're moving at some speed when it hits the ground. So could you attempt to put that into your own words? You can reuse some of what you've got here in the previous part. You reuse actually a lot of it. You just have to make sure that you switch the appropriate words. Basically, it's no longer positive. It's now negative. You're on the way down. The gravity is now not opposing motion. It's going with motion. It's going with you, the ball on the way down.
All right. Here's what I wrote so far. What else should I add?
All right, that looked pretty good here.
Okay.
The velocity is negative when the ball is falling back to the ground. And then you could say both both the velocity and acceleration are pointing downwards, causing the object to speed up until it hits the ground. Okay, that's perfect. All right. Okay, so let's look at these three scenarios and talk about acceleration. So acceleration, your background information that you need on acceleration. Acceleration causes an object to either speed up or slow down. Okay.
Okay.
So there is one scenario here, A, B, and C, where for sure the object is neither speeding up nor slowing down. Which scenario is that?
Um, I'm not sure.
Let's
Um,
let's have you go ahead and read through three scenarios. One will stand out to you as being not, it's neither speeding up nor slowing down.
C? No, wait, no.
Yes, yes.
Oh, so it's a C?
So,
The
well, we
cars.
have to answer all of them, but the answer here is that if there's no motion, there's no acceleration. Okay, so that's the easiest one to answer.
Okay. First, now let's do the skateboard. Is the skateboard coasting down a hill at two
We'll get
miles?
let's do these one. Yeah, let's do these one at a time. But so the answer here is yes, yes, and then no. The no one is the easiest. So I'd like you to try writing a sentence here that says, and you can reuse the words, of course, from the question, is that there is no acceleration, and the reason is there's no motion, and you can further add to it that it's neither speeding up nor slowing down. But that's the easiest one for you to answer. So give that a try, please.
Okay. Okay, is this what I typed? Like, does it work?
Let me take a
I
look here.
think it, I think it works.
Yeah, that's exactly right. Like that's like the full, A plus definition, answer, all that stuff. So uh the next easiest one is the skateboard. Um, I don't know if you ever skate downhill. Um, now there is there is a little bit of yeah. Have you seen any of those soapbox derby races on YouTube?
No.
Any idea what I'm talking about? So there's some pretty hilarious videos out there. People they create these um let me see if I can find a quick video. Um it's essentially this scenario here. Let me quickly look for one. Um uh, these are all a little too long, but let me see if this one's okay. Uh, this, this is only a this is only a 2 minute video. I think it's okay. Yeah, I'm gonna go ahead and watch that.
All right, let me just mute myself real quick.
You can watch, first minute or two, you'll get a sense of what's going on.
A lot of them crash don't a lot like most of the time.
Yeah, so one of the reasons they're crashing is because they are speeding up. Um,
Like actual race cars.
yes, so because you're going downhill, that's what's causing you to speed up because gravity is working. Uh, you actually speed up, which means you're experiencing, and it's due to gravity.
Mm-hmm.
So your speed will actually increase as a result.
All right.
So
But let
uh, try to put together a sentence. You can actually reuse some of the wording down in the previous one or in the sorry the subsequent one. It's up to you if you want to reuse it or not.
I think I'll figure it out as I go along. Okay, here's what I wrote.
Right. It's just because due to gravity, because you go downhill, the speed will increase. Good. Okay. So the last one's tough. The first one's the toughest to answer. The have you driven around a curve too fast yet?
No, not yet. I'm a safe driver.
You're
I think my brother has though.
okay. Have you been in the car with someone who went around a corner too fast?
No.
What? Come on.
Wait,
All right.
maybe. I don't remember. I likely
Let's
have. I just don't remember it. Or
okay.
maybe
I
I
mean, the police don't watch, Tutoring by Matthew videos to come after you, for speeding.
I really don't remember. It's a maybe
Okay.
right now.
All right. So let me ask you a different question. What happens when you skate too fast around the corner of the skating rink?
You can fall.
Well, before you fall though, what typically happens?
You gain a lot of speed.
That's right. So if your speed changes, there's acceleration. It's the
Right.
same principle in a car. In a car, when you're going around a corner too fast, your body will start to move because your body is experiencing a change in motion relative to the seat, which is fixed. But you're not. You got a seatbelt on, but it's still not enough sometimes. Or something on the floor or the dash of the car moves. So yes, the answer is yes, and it's for the same reason as the second answer. Um, it's due to gravity. Well, no, I'm sorry, it's not due to gravity. It's due to acceleration, which isn't gravity this time, but it is. So give me an answer, a full sentence there, and we'll move on.
All right. I just wrote a very simple sentence, but I want you to check it out.
Let's just reuse what's in part B. 'Cause part B's answer is very very complete. Yes, the car is experiencing acceleration as the speed will increase as it goes around the curve. What do you think of that?
Yeah, that looks good.
Okay. All right. So let's see what the next set of questions are. We can start thinking about. All right. Okay. We'll Oh, these are all together. Right. Let's see. Right. Draw the position versus time graph and the distance versus time graph for each of the following motions. All right. Position versus time, distance versus time. Okay. So the scenario here, and we'll just think about it as after reading here. Biker travels for half an hour uphill at a speed of 10 miles per hour. So you can imagine them just riding their bicycle up the hill. Then they rest for 10 minutes, so they come to a complete stop. Then they turn around and go back home. And their speed's going to be a bit faster, 15 miles per hour instead of 10 because they're going downhill. Okay, so is the scenario clear?
Yeah.
All right. So we're going to do some graphing in the next lesson, and then we'll answer some questions as well. So
Okay.
it looks like if you want, and this is, you're the customer, so you decide here. It looks like we can spend the rest of the other hour working on the next lesson. There's another bunch of questions we could answer. So if that's up to you, if you want us to do that, but
Yeah.
let's take a short break.